Hi boys and girls, Mr. D here. When you're done watching this video, hopefully, you'll be a master of graphing systems of linear inequalities. So we've done a lot with graphing lines, and we moved to graphing linear systems of lines to find out their point of intersection. Then we moved to graphing just one line inequalities, where we shaded in one side. And here we're going to take it a step further and graph multiple linear inequalities, and we're going to end up not looking at a single point of intersection, but more an area of intersection. So we'll start off with a really basic example, one that requires minimal algebra for us, but one that I think will help you exemplify or magnify here what we're trying to look at. Okay, so here's our system of inequalities. X is greater than or equal to 2, y is less than or equal to 5. So we slide out our guidelines here. This is mostly what we had when we looked at linear inequalities, with a few slightly differences here. And the differences I put in orange and blue. So again, the first thing is we would graph them as we would any line, paying attention to the inequality. So let's jump on that here. We got x is greater than or equal to 2. So greater than or equal to, it's a solid line. Okay. So x is equal to a number. That's a vertical line. Okay. Solid line. Let's use our green right here. So x is equal to 2. Bam. Greater than or equal to, I should say. Excuse me. Okay. Lightly shade in, and notice the difference. Lightly shade in one side of the line or the other. So if we do our test, point here, 0, 0, we plug in 0 for x. We try 0 is greater than or equal to 2. We know that this is not true. This is false. So that origin is not going to be colored in. So if we jump over here, the origin here, we're going to color on the other side. Now what I like to do, obviously on the computer I could do it different ways because I've got some advantages that you do not have. When I'm working with like when I'm working with my pencil on my notebook paper, what I generally like to do is I lightly just shade one direction. Just a few different lines, and you'll see why. I don't overcolor initially when I have systems of inequalities. Just a few basic lines showing the area that is covered, okay? And keep it light. Don't do it too dark. And don't do too many. Notice how I do it in one direction. I know the other day when we were practicing class, we were all kind of scribbling. Just do it in one direction. You'll see why. I think that'll make it easier for you guys. Let's jump back and look at the second equation. Y is less than, or here, step 4 says follow steps 1 through 3 for the second inequality. So we come to the second equation. We're going to graph it, right? Graph as we would any line. Y is less than or equal to 5. So solid line, because it's less than or equal to. And let's take a look. We'll use the yellow here. All right, y is less than or equal to 5. Okay, so there's where y is 5. Every point on that line has a y value of 5. Okay, now we've got to do our test point. And again, I think we see what's going to happen here. But if we do our test point, all right, plug in 0 for y because we're going to test 0, 0, 0 less than or equal to 5. Is 0 less than 5? Yeah, true. Okay, so that means the 0 side, the origin side of this yellow line gets colored in. Okay. And again, so I'm just going to color. Notice I colored side to side for that last line. So for this line, I'm just going to color straight up and down. And I would do it light with my pencil. But again, notice I put it in a different direction. Just a few simple lines here. Okay. Try and keep it in the same direction. Okay. Now go back. Now here's where we look at step 5, which I have in the blue here. Darken the shaded shared region. So if you look here, see the area where we have these sideways stripes in green and the up and down stripes in the yellow? That's our shared region. That's where they both intersect, right? We talked about when we were doing lines, we did a point of intersection. Here we're going to do an area or a region of intersection. So that's my solution area right there. So what I want to do is I really want to color in that area. So let's find a good something to color in with here. We could do it with our smiley faces. That'd be perfect. So this is our whole solution set technically over here. Well, I went over on that green line a little bit, but this is our solution area. So any point in this area here is a solution to both of those inequalities. Okay, let's erase these couple smiley faces here. Okay. So again, so x is greater than 2, y is less than 5. If you look here, any point here fits that criteria. Go ahead, take a test point here. Please write on your paper a test point. Try and pick a point that you think is in this region that fits this area where x is bigger than 2 and y is less than 5. And write that down as a solution point. Okay. And then you could pick another point, pick a second point, please, that is not a solution. Something that's not in this region here, and run it as a test. It may be a solution for one of the inequalities, but remember, it's got to be a solution for both in order to be in this region. Okay, that's a pretty easy one. Let's take a look at a slightly more challenging one here. Okay, so here we got real equations now. These are most likely what you're going to get. Bring out the steps. You don't have to recopy these down. Both our inequalities are in standard form. I know a lot of you guys are going to move these over to get the y's alone. Let's fight the urge to do that. Okay, let's just plug in. We plug in 0 for x here in this first equation. That cancels out the x, and we get y equals 10. It's a lot easier than moving things in the slope-intercept right now. Okay. If we plug in 0 for y, okay, 5x equals 10. If x equals 2. Let's do the same thing for the second inequality while we're doing that. Okay, 0 for x, well, y equals 15. Okay, and then 0 for y. Sorry, guys. 0 for y, x is going to be 7.5. Okay, so let's graph these. Now, if you look here, we have we don't have the equal sign, so these will be dotted lines. So let's take a look over here and let's graph these. We're going to have to change up our scale a little bit here for the sake of what I've got here. We'll make this 15. Make this 10. Let's do this. Yeah, better idea. Sorry, guys. Let's make this 5, 10, 15, and so on. Okay. So we take a look at our points. We got x is 0, y is 10. Okay, so then this is 5, 10. Just ignore these numbers here. Okay, guys. So x is 0, y is 10. Graph. Alright. Our other point, x is 2, y is 0. X is 2. So if this is 5, x is 2 will be right about here. Now let's get a dotted line to connect those. What? Not what we wanted to do there. This is what we wanted. Sorry, guys. Alright, so roughly. You got the general idea. I got my arrow there, I got my arrow there. Okay, let's take a look at the second line. X is 0, y is 15. Alright, x is 0, y is 15. We'll use a different color. X is 0, y is 15. If this is 10, be right there. Okay? And then we've got x is 7.5, y is 0. So 7.5 would be okay, so 7.5 would be right about in here. Right? Alright, let's get our line here. It almost looks like a parallel here. I think if we check the slopes, not exact, but okay. Yeah, they look almost parallel. But again, if you check the slopes, they're not quite exact. This line, the first line we graphed, is -5, and the second graph is -2. So they're close. Let's do some test points for these guys now, okay? Let's do a test. If we test this first line, okay? So right over here, plug in 0, 0. So you got 0 plus, because 5 times 0, so I'll write it out for you guys. I don't want to skip too many steps here. 5 times 0 plus 0 is greater than 10. So we get 0 plus 0 is 0 greater than 10. Well, obviously, it's not true. It's a false. So on this first line we graphed here, and the one thing I should have, yeah, so the first line we graphed, you can't lose sight of which line is which. 0, 0 is not a solution. So we're going to color in this other side. So just like I said in the last video, color in one direction. So I'm going to use lines, sideways lines for right now. Okay. So I'm not coloring the 0, 0 side. Alright, now we've got to figure out what the shared region will be with the other line. So let's take our test points for the other line. Okay. Bring our other line down here. Here's our points. 2 times 0 plus 0 less than 15. Alright, 2 times 0 is 0, 0 plus 0 is 0, so 0 less than 15. Well, yes, we all know that is true. So when I go to my graph here, and I'm going to use the same color here just so you guys can see what it looked like on your paper. When I go to my graph here, this second line now, I do want to include the origin 0, 0. So I'm going to color in this side. And notice, like I said, I do one line sideways, the other one's up and down. It doesn't matter which is which. But now what I can see is this helps me see where they intersect. Alright, and so I can see right in here is where they intersect. And again, you guys are most likely going to be working with the same color. So I'll keep everything the same color, just so you can see how I would handle that situation. I would color in that shade. I would shade in that shared region right in here. Okay, so this is the area where those inequalities intersect. Okay, not a point, but an area. Okay, so hopefully this helps you out. Remember these steps. Okay, I think the keys, because some of the graphs can get pretty complex and messy. See how I just shade lines in one direction, one the other direction. We could easily pick out where they intersect. Okay, hope this helps. I know this was a long video. Hopefully you stayed with me, and I'll see you guys in class. Peace.